Good morning, good morning. Got a few people still trying to connect, so let's go ahead and give them that chance.
Good morning, Mr. Tuck. I have a quick question.
Yes.
I was wondering if I can talk to you at the end of the class about one of the tests.
Yeah, sure.
Okay.
Cool. All right. Let's use everybody in. Still got somebody trying to connect, but it'll be all right. So, good morning. Hope all is well. Hope everybody's doing all right. Hope you had a great weekend. Excuse me. Let's see. Did anybody have any general questions? Try anything, get stuck before we get rolling? Hold on, let's see.
Mr. Tucker.
Yep.
I got some construction going on. They got to rebuild my kitchen today.
Okay.
You might not hear from me too much, but
okay. Okay, yeah, that's not a problem. Thanks for letting me know. All right, so we have done chapter 10, 6. So we're looking at 12 today. Let me see something. Okay. Trying to find my exponents. Okay. All right, so let's see. So today if we do 12, 1. So is anybody prepared to take a test? Not today. I'm talking about is anybody in position right now to be able to take a test? But like I said, not today. Like in other words, if I were to offer the opportunity next class to take a test, would anybody be ready, or that's just not anything ready for right now? Because I know somebody has already taken the test already, but I don't know how many people haven't checked that out.
I'm ready.
Okay.
Me
I'll
as
be
well.
ready to take chapter 10 test. I already did chapter 9.
Okay. Okay, so we'll do that next class. I mean, today we'll get started in chapter 12, but next class, we can go ahead and do a test. It doesn't matter which test you want to take. What you have to do is come to class, make your camera available. I'll be prepared to make your camera available. So you make your camera available, show your ID to the camera. And then I will give you the password for the test that you're trying to take. You let me know which test you're trying to take, and then I'll give you the password for that. And then you would take it. And then you stay on. Of course, you don't just roll on. You stay on until you're done taking the test, submit it and everything. And then that's when you can log off. Okay, so if you're not coming next class to take a test, then you don't have to come to next class. The next class, which is Thursday, we'll take time out and make it an opportunity for you guys to be able to take one of your tests. All right, any questions on next class? Everybody good? Understand what we're doing? Okay. So let's look at chapter 12 today. (12.1) exponents. So, like I said, it's 12.1, not 6.1. So if you have 2 to the third power, which is what we have right here, the regular size number is your base, that's 2. And then the superscript number, smaller number up to the right is your exponent. So what that means is that you're going to take 2 and multiply it times itself 3 times. So that's what we did right here. And then that will give us 8. 2 times 2 times 2 is 8. Now, if we were to switch the roles, you will not get the same number, because what we have now is that the base is 3 and the exponent is 2. So that's 3 times itself twice, which will give us 9. So just always make sure you're applying the base, applying the exponent to the base properly. Questions on how exponents work before we go to the next piece? All right. The next exercise says write by using exponents. I don't know why I wrote it that way. So write by using exponents, and they give us 2x times itself 4 times. So you can rewrite it as 2x. Notice you have parentheses, 2x to the 4th power. All right. So you have to be careful here with that. I don't know what I was doing here. Okay, I wrote it down here. Okay, so you have to be careful here and make sure you actually use parentheses. Use parentheses right here. Because that's saying you're raising 2x to the 4th power. If you do not use the parentheses, that's what I explained right here in the red. So in the first statement with parentheses, exponent of 4 is being applied to the 2x. Or when you don't use parentheses, then that 4 is only applied to the x. So that's why you have to use parentheses if you're trying to apply the exponent to both 2 and the x. Because if you do not, the 4th power is only being applied to the x. So that's the difference in using parentheses versus not using your parentheses. All right. Here, just I'll give you another example to reiterate that statement. Here, if you have x, y, z parentheses to the 5th power, x, y, and z is affected by the exponent. But here with no parentheses, just the z is affected by the exponent. All right. So the next exercise, we were same type of deal, but we're dealing with negatives to make sure that we understand what is affected by your exponent, what isn't. We have these negatives involved and no parentheses. So looking at this first one, we have -4 squared. Hold true to what we just finished mentioning. There is no parentheses. So the thing that's right up against, or the number that's right up against the square, is the only thing that's being affected by the square. So that means this negative sign is not being affected by the exponent at all. So that's 4 that's being squared. So that's -4 times 4. And then that's going to be -16. Now, if you want to include the negative as a part of being affected by the square, you have to use parentheses. And so notice that's what happens here. -4 times -4 gives you a +16. So having parentheses versus not having parentheses matters in all cases when you're dealing with these exponents. Questions? Any questions? All right, so same thing as if we had a fraction, that doesn't change. We have -4/5 raised to the third power. So that's -4/5 times itself 3 times. Now, negative to a negative will turn positive. So those turn positive, but you still have a negative left. So 4 times 4 times 4 is 64. 5 times 5 times 5, 125. So that's a -64 over 125. All right, any questions? This is just regular. Somebody must have asked me a question right here, just regular add, subtract and stuff that has nothing to do with exponents. Everybody done with this? I can scroll up. So let's look at our exponential rules. So we'll just list them out and then we'll go through each one of them with examples. So the first one, x to the n power times x to the n power. Notice the bases are the same. So if that's the case, we will add our exponents. If we're dividing, so when we're multiplying, we're adding them. If we're dividing, once again, bases are the same. We subtract our exponents. X times y raised to the n power. We can apply that m to each one of those numbers or terms. X to the m, y to the n. Same thing with division, x over y raised to the n power, that m can be applied to each term. So that's x to the m over y to the m. Five,
Just have
six,
to, if you
six.
slow down a little bit.
Okay. Now, did you get 1 and 2?
I got one. I got 1 and 2.
Yeah.
I'm just trying to understand a little bit. I was kind of following, but I got a little confused.
Don't worry about it right now. We're going to go through examples with them all. I'm just telling you what's up there. Yeah, we're going to walk through an examples with each one of the rules. Yeah.
Okay.
So I'm not really explaining right now. I'm just telling you what I got written on the, on the left. So yeah, we good. We good. I'm gonna make sure we straight. All right. So 5, 6, and 7 just dealing with negative exponents. Showing that if you want to rewrite it as a positive, you can bring it down to your denominator. And if it's in your denominator negative, to rewrite it as a positive, you can bring it up to your numerator. And then if you have a fraction and it has a negative exponent being applied to it, you flip that fraction. So all three of those are just dealing with negative exponents. All right, done with 3 and 4. Number 8, anything to the first power is itself. Anything to 0 power is 1. And 10, I should have wrote that, probably one of the early ones. I remembered it last, but if you raise a power to another power, you multiply the exponents. So normally that's one that's higher up on the list, but I forgot until I wrote it down there. I knew it was 10 of them. But yeah, we're about to walk through each one of them with actual examples. Give you guys a chance to finish writing them down. All right, we're good to go ahead and try some of these. I'm done writing the rules. All right, so let's look at the first one. X to the nth power times x to the nth power. Once again, we have the same basis, so that means we can add our exponents. So if we look at that first one, w cubed times w to the fourth. If you will look at the breakdown of that, w cubed is www. W to the fourth is www. So that's 3 w's and 4 w's. So if we were to multiply those together, all together, we would have 7 w's. And that's the foundation of all of that, of all of these rules. If you were to expand them out and then simplify, then you would get these numbers. So these are really shortcuts to the expansions. So if you have w to the third power times w to the fourth power, you can just add the exponents and that'll give you your ultimate result, which is w to the seventh power. So that's what the first rule is stating. Now, if they are different letters, then of course you can't apply the rule. It's about having the same base, or in other words, the same number. So here, 2 to the 11th times 2 to the 8th. Once again, the base is 2 in both cases, so you can just add the exponents. 11 plus 8 is 19. The next one, y times y to the 9th times y to the 17th. If you just see a variable there with no exponent, they assume you know there's a 1 there. So that would be 1 plus 9 plus 17, which will give you y to the 27th power. Any problems with what we've done so far? Next one, right here, ab to the 5th times a cubed b to the 8th. So remember, this rule only applies to those with the same basis, or in other words, the same letters. So the only thing that we can combine are the 2a variables and the 2b variables. And that's what I did right here. This next step, notice I have a times a cubed in parentheses, then b to the 5th times b to the 8th in the second set of parentheses. All of this is multiplication, so you can move around your terms however you see fit, whichever way will make you or enable you to simplify further. So I move my a's together, move my b's together. And so that's a to the 1st times a to the 3rd. That'll be a to the 4th. And then b to the 5th times b to the 8th will be b to the 13th. And that would be your most simplified answer. All right. So any questions on rule 1 before we go to rule 2? All right. Second rule, x to the m over x to the n. Whenever you divide, the first rule, when we multiply, we add on our exponents. When we're dividing, we're subtracting our exponents. So here, t to the 6th over t to the 4th. 6 minus 4 would be t squared. Next one, 5 to the 10th over 5 to the 8th. 10 minus 5, 10 minus 5, 10 minus 8 is 2. And then something like this, 5 squared, they do are expecting you to go ahead and simplify that to the 25th, not 25th power, to 25, because 5 times 5 is 25. Notice when we were up here, I left that as 2 to the 19th because that's a very, very large number. They don't expect you to go that far. But something like a square, cube, 4th power, they would expect you to go ahead and multiply that out. Next one, y to the 15th over y to the 8th. Once again, subtract your exponents, that's y to the 7th. All right. Any questions on either one of those two rules before we look at some more? All right, can we go to the next one? All right, so this rule is the third one we're going to talk about, but it's actually number 10. Because remember I said I meant to write that one earlier in the rules. So it's actually rule number 10 according to the list that we have. All right, so whenever you're raising an exponent to another exponent, it says that you multiply your exponents. So you're raising a power to a power, you're going to multiply your exponents. So s to the fourth, that is a s. So s to the fourth raised to the second power. Once again, what we have here is a power to a power. So that means I will multiply. All right, and 4 times 2 will be 8. All right. 3 to the 10th raised to the 5th power. 5 times 10 is 50. All right. This one right here, x squared times x to the 5th raised to the 4th. So if you can simplify what's in the parentheses, you should go ahead and do that to make a simple calculation or a simpler calculation for yourself. So inside of here, since we have the same variable, we can go ahead and add our exponents. And so that's why we have x to the 7th. And then power to a power. 7 times 4 will give you 28. Any problems? Any problems? So everybody good with a power to a power? You multiply your exponents. All right, next one. Two different things or two different terms being multiplied to each other, but raised to an exponent. I can apply the exponent to each one of them individually, x to the m, and then y to the n will be the result. So looking at the first one, under this rule, we have -2 xyz. And it's raised to the 4th power. So that 4th power needs to be applied to each one of those terms individually inside of the parentheses. And so that's what I did right here. -2 raised to the 4th power, x to the 4th power, y to the 4th power, and z to the 4th power. -2 times itself 4 times will give you 16. And the others just are what they are, x to the 4th, y to the 4th, z to the 4th. All right. Next one, 5x squared, y to the 7th cubed. And just like the last one, you apply the 3rd power, or you apply the exponent that's in you know, to each term that's in the parentheses. So in this case, it's the third power. So it's 5 cubed, x squared cubed, y to the 7th cubed. All right. 5 cubed, it's 125. Then we have x squared cubed. 2 times 3 give you 6. Then y to the 7 cubed. 7 times 3 give you 21. Any problems? Any problems?
No, sir.
Mhm. Next one's very similar. This time we're looking at division, in which the m or the exponent can be applied to both parts that's in the parentheses, top and bottom, exponent, numerator and denominator. So we have 2/5 raised to the third power. That cube needs to be applied to the 2 and to the 5. 2 cubed, 2 times 2 times 2 is 8. 5 cubed. 5 times 5 times 5 is 125. So it's just 8 over 125. All right. 2x cubed over y to the 5th raised to the second power. And your exponent has to be applied to each term that you see. So you have 2 and x cubed, that's in the numerator, y to the 5th in the denominator. So you see that my squared is applied to 2, x cubed. So 2 squared is 4, x cubed squared is 6. For your exponent, 3 times 2, power to a power. Same thing here, power to a power. 5 times 2 give you 10 for your exponent. Any questions? Any questions? All right. Let's scroll up. Everybody good? So here they give us one to just tell us to simplify, and they want us to use our exponent rules accordingly. Hold on one second. Let me check out something. Okay. So negative exponents will show back up in 12.5. Okay, just wanted to make sure. All right, so we can simplify x squared to the 6th power by multiplying your exponents. So that's how we get 12.
Can
Same
you
thing.
go up to the top one more time? Let me write down that top. I'm sorry.
Which one? That one? How far?
Oh, never mind. I think I'm good.
Okay.
I missed it. Good.
Yeah, if you got thrown off by this, I was just checking out something. I said, hold on, let me check out something real quick. Yeah, that's not till 12.5. Yeah.
All right.
So you're good to go. Let me get back here. There you go. All right. So x squared to the 6th power, 2 times 6 will give me 12 for my exponent. Down here, 7 times 2, 14. All right. And now I can simplify my numerator because they're being multiplied together. I can add my exponents. So 12 plus 3 is 15. And now that these are being divided, I can subtract my exponents. And 15 minus 14 is 1. And that'll just be x. All right. Make sure we're okay with the simplification. All right, I'll scroll up. All right, here we have 3c d squared times 2c d cubed raised to the third power. So this cube right here needs to be applied to each piece in that second parentheses. It does not affect the first parentheses. So the first parentheses stay the same, just 3cd squared. But then we have 2 cubed, c cubed, d cubed cubed. All right. We can simplify that by doing 2 cubed, which is 2 times 2 times 2, that's 8. D cubed cubed, remember the power to a power, you multiply your exponents. So we have d to the 9th. All right. So now this, just like before, you break up and even if you don't write the statement out, this is how you process it mentally, right? 3 times 8 would be one thing that you would do. C times c cubed would be the next thing, and then d squared times d to the 9th would be the last simplification that you would do. And so 3 times 8 is 24. C times c cubed is c to the 4th, because 1 plus 3 give you 4. And then d squared times d to the 9th would be d to the 11th. Add your exponents. All right, questions, any questions? All right. Okay, so next thing is just emphasizing the zero exponent. So anything to the 0 power is 1, whether it's a number or a variable. Here, -4 to the 0 power is 1. Once again, revisiting what we initially talked about with these parentheses, make sure you're careful. Now here you have -4 to the 0 power without parentheses. So that 0 power is only being applied to the 4. That negative is not affected. So that's why the result is -1. Before, -4 was being affected by the 0. That's why I turned it into +1. Anything affected by the 0 power is +1. But if you don't have it affected, then it's still there. So the same thing happens here. We have -4 x to the 0 power with no parentheses. That means the only thing that's affected by the 0 power is x. So it's -4 times x to the 0 power, which is just 1. -4 times 1 is just -4. Here, because parentheses are around the whole 4x, all of 4x will go to 1 because of that 0 power. All right, questions, any questions? All right, so we'll come back to the negative exponents. Remember, that's 12.5 for us. And let me do this. Just write myself a note. Just write myself a note there. See how much of this we want to do today. Class needs all that. Yeah, we can do this. Okay, so we'll look at adding, subtracting polynomials, and then we'll be done for today. All right, so polynomials, just an expression that has variables, operations, exponents, etc. So the three different examples right there of a polynomial. X plus 5, 15x squared by itself is considered a polynomial. It's considered a monomial. It's one term. And then 3x cubed plus 7x minus 9 is a polynomial. All right. Your terms are separated by plus or minus signs. So if we have 3x cubed plus 7x minus 9, there are three terms there. 3x cubed, 7x, and the negative 9 are terms. Your coefficient, that's the number that's in front of the variable. So we go back to those three terms. If we look at 3x cubed, this 3 that's sitting in front is your coefficient. 7 is your coefficient, and negative 9 is a coefficient as well. All right. The degree of a term is the exponent on the variable. So 3x cubed, this 3 right here is your exponent. For 7x, it's 1. And then for negative 9, where you don't see anything, 0 is your exponent. Then the degree of the polynomial is the largest exponent in the polynomial. So in this case, it would be 3. So it's a third degree polynomial. Then your constant is the number that's not attached to a variable at all. And in this case, it would just be that -9. All right, so you normally ask to arrange your terms in descending order. So that's arranging your terms from largest to smallest according to your exponents. So 5x to the 7th plus 4x to the 6th plus 3x cubed minus 2x minus 8 is writing it in descending order. Once again, writing it from largest to smallest. And that's the one according to your exponent, and that's the one that we normally use. In ascending order is the opposite, arranging your terms from smallest to largest according to your exponents. So I just took what the previous example and just reversed the order. That's -8 minus 2x plus 3x cubed plus 4x to the 6th plus 5x to the 7th. All right, monomial is one term. Binomial is two terms. Remember, your terms are separated by plus and minus signs. Trinomials, three terms. Polynomial itself, if you're being specific, normally refers to four or more terms. Any questions? Any questions?
No, sir.
All right. Very good. So, hold up. Let's multiply this 12, 3. Okay, here we go. So, we're still in 12-2. Still in 12-2. But now we're looking at adding, subtracting polynomials. And then we'll be done for today. So if we talk about adding, subtracting polynomials, you have to figure out or make sure you have your like terms. Like terms are terms that you can add and subtract from each other with no problems. So in order for them to be like, they have to have the same variables, same amount of variables, same exponents on your variables. So this first column, just examples of like terms, 5x and 3x, 10x squared, negative 17x squared, negative 39x squared y, 101x squared y, and even 8, 30, and 73 are considered like terms. There are terms that have same variables, same amount of variables, same exponent on your variables, or no variables at all are like terms. If anything is different, they are unlike, you cannot add them or subtract them from each other. So 5x and 3, one has x, the other one doesn't. There's nothing you can do with that. 3x squared, negative 17x, one has x squared, the other one doesn't. Cannot add or subtract them from each other. And then the next one, one has x squared y, the other one has just xy. So you would not be able to add them or subtract them from each other. Mhm. Let's scroll up. All right, so the next set of expressions are just variations of the same terms where you would be able to add terms together and where you would not be able to add terms together. So the first one, 5x and 3x are like terms. So just go ahead and add them together. That's 8x. All right. Just add the numbers, the coefficients, the numbers that are in front of variables. 5x plus 3, one has x, the other one doesn't. So you cannot add them together. Then it's already in lowest terms. There's nothing you can do with that. 5x plus 3y, same type of deal. One has x, the other one has y. You cannot add them or subtract them from each other. In this case, we're talking about adding. So that expression is already in lowest terms. 5x squared plus 3x squared. Both of them have x squared. So just add the 5 and 3. So that'll be 8x squared. You don't mess with the exponent. You just add the numbers that are sitting in front of your variables. Then for the last one, one has x squared, the other one doesn't. The other one has just x. So that expression is already in lowest terms. All right. Any questions on any of these scenarios before we go ahead and simplify a few expressions? All right, directions would just be simplified, and they would expect you to know to combine your like terms. So 7x squared y plus 20x squared y minus 8. We have two like terms here in the 7x squared y and the 20x squared y. So you add those together. That gives you 20x squared y. The minus 8 you cannot combine, so you just bring it down. Very good on that one. All right. So the next one, negative 3c cubed plus 5c squared minus 7c plus 11c cubed plus 6c squared plus 3. So you're going to combine your like terms. Anything that cannot be combined with anything, just go ahead and bring it down to your final answer. So we have negative 3c 11. I said negative 3c cubed. Okay, make sure I say it all. Negative 3c cubed plus 11c cubed will give you 8c cubed. It's negative 3 and 11. Then we have 5c squared and 6c squared. Adding those together will be 11c squared. Now the negative 7c, there's no other c term, so you just bring it down. And then a positive 3, there's no other constant, so you just bring that down. And what's in the box would be our final answer. Any questions? Everybody good? So the next one, 4w squared minus 2x plus 3w squared minus 4x squared plus 6x. So once again, you only look for like terms. So we have 4w squared and 3w squared, which will give me 7w squared. Then we have negative 2x and 6x, which would be a positive 4x. And then negative 4x squared, excuse me, can't combine with anything, so you just bring it down. So just make sure you're careful. Any problems? All right. So the next one we're doing is subtraction. The main difference between addition and subtraction of these polynomials is that subtraction has this first step of making sure that you apply each term, apply the negative to each term that's in the parentheses that follows the negative. So we have negative p to the fourth plus 5p squared minus 3 minus the quantity of 11p squared plus 4p minus 6. So the first thing you want to do, whether you write it out or not, is make sure that you apply the negative to each term in that parentheses. So that'd be a negative 11p squared minus 4p plus 6 now. All right, any questions on that? All right. Once you've done that, now you can just combine your like terms the way you do it any of the other terms or any of the previous problems. So looking at 4p to the fourth. I said something. All right. So looking at 4p to the fourth, there's no other p to the fourth term, so you can just bring that down. If we're writing in descending order, then we're looking for p cubed. There's no p cubed, so we're looking for now p squared. So we see this one and this one. So 5p and negative 11p, or 5p squared and negative 11p squared is negative 6p squared. Then we see p, there's no other p term, so that negative 4p, just bring it down. And then to finish it off, negative 3 and positive 6 is a positive 3. Any questions?
Yes, sir.
All right. Next, the last one. So same type of deal here. We have a squared minus 2ab plus 7b squared minus the quantity of negative 8a squared minus 6ab plus 2b squared. So because it's a minus sign in front of that parentheses or between our parentheses, we give it to the one that follows. And that turns the 8a squared positive, 6ab positive, and the 2b squared negative. All right. Combine your like terms accordingly. A squared plus h squared is 9a squared. That's 8a squared plus h squared. It should be a squared plus 8a squared is 9a squared. Then we have negative 2ab plus 6ab, which would be a 4ab. And then 7b squared minus or plus negative 2b squared give you 5b squared. Questions on anything? Any questions? Okay. So that's it for today as far as lecture is concerned. That's 12.1 and 12.2. Next class, we'll get into 12.3, which is multiplying your polynomials. Oh, not next class. That'll be Tuesday. We'll get into 12.3. Next class, I said I'll open up the floor for you guys to take a test. So once again, if you're not going to take a test on Thursday, then you do not have to come to class. Or if you have plans to take it with Mr. Davis, then you don't have to come to class. It's not a big deal. Doesn't matter who you take it with. Results will still be the same. Other than that, you guys have a good one. Be safe, and I'll see you next class. Unless somebody in the chat said they had a question. So you want to sit back for his question, feel free to do so. Other than that, you can have a good one. All right, take care. All right. Yes.
Yeah, you kind of answered my question earlier. I was just asking because I emailed you and Mr. Davis last week about taking one of the tests, but since we get to take it next class, I'm all good.
Okay. All right. Sounds good.
All right, thank you.
All right, take care.
Thank you, you too.
All right. If you got that question, you can feel free to ask it.
How's it going?
I'm good. How about yourself?
It's the questions where it's asking me to graph the inequality. And the problem is x minus 4 less than or greater than -4. So how would I go about solving that?
Now is it less than or equal to?
Yes.
Okay. And so you have that right there, x minus 4 less than or equal to -4?
Yes.
Okay. So you would go ahead and solve by adding 4 to both sides. 4's cancel. On the left leaves you with x less than, and in actuality, -4 and +4 on the right cancels as well, and that'll be 0. So
then I just graph it as the 0.
and you're talking about less than 0. You're going to shade to the left, but then you would use a bracket and shade to the left.
So is it possible for me to schedule the test for the 9s and then do the test that I'm missing for 10s with you?
Now when you say schedule it, now next class, I'm opening up the floor for you to be able to take a test. So you don't have to schedule that. You can just come to class and be ready to take the test. So that's
and how many questions are there?
Oh, I have to look at it. You can email me, shoot me that email. I have to go look it up. So I don't know how many questions are actually up there. But if you're trying to take your test next class, you don't have to schedule it. You can just come to class and then you can take the test. But if you want to schedule it and you don't want to take it next class, then yeah, you would shoot Mr. Davis that email, and he may have some other times, not may, but he will have some other times available for you to be able to take it.
Okay.
Yeah.
So I'm only missing one test, right? Or am I about to miss?
You say you haven't taken chapter 9's test yet?
No.
Okay, so it's 2 now because you got 9 in chapter 10.
Okay.
But you're not, that far behind or anything like that. A lot of people are in that same position. That's why I'm offering the opportunity to take one of your tests, next class.
Okay.
Yeah.
Thank you.
All right, not a problem. You have a good one.
You too.
Mhm.